Stars are born in the coldest, darkest places in the universe. Scattered across every galaxy are vast clouds of hydrogen gas and dust called nebulae, some stretching across hundreds of light years. These clouds are so cold that their temperatures hover just a few degrees above absolute zero. They drift in silence for millions of years until something disturbs them. A shock wave from a nearby supernova, the gravitational tug of a passing star, or the pressure wave from a spiral arm sweeping through the galaxy. The disturbance compresses a region of the cloud, and gravity takes over. Once a pocket of gas begins to collapse, it cannot stop. Gravity pulls more material inward, and as the cloud shrinks, it heats up. The collapsing core spins faster and faster, like an ice skater pulling in her arms, flattening into a rotating disk with a dense, glowing ball at its center called a protostar. Over 100,000 years, the protostar grows hotter and denser as material from the surrounding disk rains down onto it. Temperatures at the center climb to millions of degrees. The protostar glows with infrared light, invisible to human eyes but detectable by space telescopes peering through the dusty cocoon that still surrounds it. When the core temperature reaches about 15 million degrees Celsius, hydrogen nuclei begin to fuse into helium, releasing enormous amounts of energy. The star ignites. A blast of radiation and stellar wind blows away the remaining gas and dust, revealing the newborn star for the first time. It has joined the main sequence, the long, stable phase where it will spend most of its life balancing the inward pull of gravity against the outward push of fusion energy. Our Sun has been on the main sequence for about 4.6 billion years and will remain there for roughly another 5 billion. How long a star lives depends almost entirely on its mass. Small red dwarf stars, which make up about 70% of all stars in the galaxy, burn their hydrogen so slowly and efficiently that they can shine for trillions of years, far longer than the current age of the universe. No red dwarf has ever died of old age because the universe is not old enough. Our yellow sun will live about 10 billion years. But massive blue giant stars, dozens of times heavier than the sun, burn through their fuel in a frantic blaze and may live only a few million years. They are the brightest stars in the sky, but they are also the most short-lived. The candles that burn brightest burn fastest. When a sun-like star exhausts the hydrogen in its core, the core contracts and heats up while the outer layers expand enormously. The star swells into a red giant, growing so large that it could swallow the inner planets of a solar system. Our sun will expand to roughly the orbit of Earth. The bloated star pulsates, shedding its outer layers into space in shells of glowing gas that form some of the most beautiful objects in the universe, planetary nebulae. The Helix Nebula, the Ring Nebula, and the Cat's Eye Nebula are all the glowing ghosts of dead stars. At the center of each one lies a tiny, incredibly dense white dwarf, the exposed core of the star that was, no larger than Earth but containing half the mass of the Sun. Massive stars die in a far more dramatic fashion. After fusing element after element in their cores, building up layers like an onion with iron at the center, they reach the moment when fusion can no longer support them. The core collapses in a fraction of a second, and the star explodes as a supernova, blasting its outer layers into space at tens of thousands of kilometers per second. The explosion forges elements heavier than iron, gold, platinum, uranium, and scatters them across the cosmos. Every gold atom in every wedding ring on Earth was forged in the death throes of a star that exploded billions of years ago. What remains after a supernova depends on the mass of the core. If the core is between about 1.4 and 3 times the mass of the Sun, it becomes a neutron star, a city-sized ball of matter so dense that a teaspoon of it would weigh 1 billion tons. Some neutron stars spin hundreds of times per second, sweeping beams of radiation across the sky like lighthouses, objects we call pulsars. If the core exceeds about 3 solar masses, nothing can halt the collapse, and it becomes a black hole. But the material the supernova scattered, enriched with heavy elements, mixes with nearby gas clouds, and eventually collapses to form new stars and new planets. We are made of star stuff, as Carl Sagan said, And the cycle of stellar birth and death is the engine that built every atom in your body.